Picture this, the Himalayas, Nepal nestled right below incredible, powerful river systems like the Karnali. Breathtaking landscape, but it's also incredibly vulnerable to nature's power, especially when it comes to flooding. So we're going on a deep dive today looking at a really interesting research study actually from June 2023 that used some really cutting edge machine learning to map out areas most likely to flood in the Karnali River Basin. Now, the Karnali River, it's Nepal's longest river. It flows from the Tibetan Plateau all the way down to India. It's fed by glaciers and some really intense monsoon rains, and where the river meets those plains, it's called the Terai region, and that's where it becomes particularly vulnerable to flooding. You've got flat terrain, heavy sediment deposits, and then a rapidly growing population. It's a recipe for potential disaster. So in this deep dive, we're going to uncover those factors that make an area prone to flooding, explore how machine learning can help us predict these events, and find out which parts of the Karnali River Basin face the greatest risk. And joining me to help us understand all of this is an expert in the field. One of the things that really struck me about this research was how they use satellite imagery and data from like WorldClim and even the Nepal government's disaster portal to pinpoint where floods have happened historically. And those past flood locations, along with data on areas that didn't flood, became the training data for their machine learning models. It's like teaching a computer to recognize a flood's fingerprint.
Yeah, it really is a fascinating approach. The algorithm learns from all that training data, almost like it's studying a flood's history. And then it can use that knowledge to predict where future floods might occur.
So it's more than just looking at a map and going, oh, that area's low-lying, it'll probably flood. This is using data to teach a computer to see those patterns that we might miss.
Precisely. And, they examine 10 different factors that can influence flooding.
10 factors. Wow. Okay, so let's break those down for our listeners. We've got elevation, we've got slope, we've got aspect, and that's basically which direction that slope is facing. There's curvature of the land, soil type, rainfall, the stream power index, which measures the erosive power of the river, the topographic wetness index, which looks at how water accumulates. We've got distance to the river, and then something called the normalized difference vegetation index, or NDVI, and that tells us how dense the vegetation is in an area. It's amazing how much goes into understanding these floods.
Yeah, it's definitely complex, but by breaking it down into these factors, it allows us to start to really see that bigger picture.
Now, here's something that I thought was really interesting. Typically, the direction a slope faces that aspect is a really big deal in flood studies. But in the Karnali River Basin, it didn't seem to really matter as much. Any thoughts on why that might be?
It's probably due to the unique geography of the Karnali River Basin. Generally, we think of north-facing slopes as receiving more rain. But in the Himalayas, the north side of the mountains actually creates what's called a rain shadow, meaning it receives less precipitation.
So the very thing that might normally make an area more flood prone is actually having the opposite effect in this case.
Exactly. And it really highlights how important it is to consider the specific context of the region when we're looking at these things.
Now, to test the importance of each of these 10 factors, the researchers used a really interesting method called leave one out cross-validation. And, we don't need to get into all the technical details here, but the main takeaway is that they were able to pinpoint the factors with the absolute biggest impact on their flood predictions.
It's kind of like figuring out which ingredients in a cake recipe are essential and which ones you could maybe adjust a little.
Okay, I love that analogy. So what were the key ingredients? What were the top predictors of flood risk in the Karnali River Basin?
Well, the study actually found that vegetation density measured by that NDVI we talked about was the most important factor. And then came elevation distance to the river, the curvature of the land, and how wet the soil is. That topographic wetness index.
Okay, so dense vegetation, that's good. It acts like a natural sponge, right? And then the closer you are to the river and the lower the elevation and the wetter the ground, that all means higher flood risk. It's really starting to paint a picture here.
It really is all about understanding these interconnected factors and how they contribute to that overall flood susceptibility.
Now, to make all these predictions, the researchers used 3 different machine learning models. Kind of think of them as these super-powered prediction engines. There was support vector machine, random forest, and artificial neural network, each one using different algorithms to kind of crunch the data from those 10 factors we talked about.
Yeah.
But this is where I get curious. Which one performed the best? Which one came out on top as the best flood predictor?
On the support vector machine, SVM for short, it really outperformed the others.
So it was the star of the show.
Yeah, you could say that. It achieved a really impressive 92.8% accuracy when it was fitting the training data. and then a remarkable 98.7% accuracy when predicting flood susceptibility in new areas.
Wow, those are some really impressive numbers. I mean, that kind of accuracy could be a total game changer for predicting and preventing floods. So tell me, based on all this data crunching and analysis, which areas were flagged as the most vulnerable to flooding?
Well, it looks like the lower portion of the Karnali River Basin, right where it flows out onto the plains, that really stands out as the area of greatest concern.
And why is that?
Well, it's a few things. The area is low-lying, it doesn't have a lot of dense vegetation, and it has what's called a braided river pattern.
Okay, so braided river pattern. What exactly does that mean, and why does it increase flood risk?
Well, imagine a river that splits into multiple channels, almost like the strands of a braid, interwoven.
Okay, yeah, I can picture that.
And that pattern creates a much wider area where flooding could potentially happen, which makes the lower Karnali River Basin particularly susceptible to flooding. And you know what makes it even more concerning?
What's that?
Rapidly growing cities like Tikapu, Rajapur, and Madhwan are located right in that high-risk zone.
So we have a lot of people living in an area that's very vulnerable to flooding. That's a recipe for trouble.
It really highlights how important it is to start implementing some effective flood management strategies. And, going back to what we were talking about earlier, vegetation plays a crucial role. If we can preserve and restore the natural vegetation in the area that can really significantly reduce that flood risk, it's almost like building a natural defense system.
It's not just about building walls and dams. It's working with nature to protect ourselves.
Exactly. And, while these machine learning models are powerful tools, it's important to remember they are just that, tools. They need to be used in conjunction with real-world observations and local knowledge.
So it's about combining cutting-edge technology with the wisdom of those who actually live and work in these areas, blending science and experience.
Precisely. And that leads to the next really crucial question. How do we take all of this incredible knowledge and turn it into action? How do we bridge the gap between the data and real-world solutions that will actually protect communities?
Such a good question, and the perfect segue to the next part of our deep dive, where we explore some of the practical applications of these findings and how they can help create effective flood mitigation strategies in Nepal. So we've uncovered some incredible insights about flood susceptibility in the Karnali River Basin, all thanks to the power of machine learning. But having that knowledge is only powerful if we use it right. So let's shift gears for a minute and talk about what we can actually do with this information. How do we turn these cutting-edge predictions into solutions that actually protect people in those areas?
That's the million-dollar question, isn't it? Bridging that gap between the science and society, between the data and taking action.
Right. We could have all the fancy algorithms in the world, but if it doesn't help people on the ground, what's the point? It's almost like we need to put on our city planner hats for a minute. If we were tasked with protecting these communities, where would we even start?
Well, I think the first thing to remember is that the people living in these flood-prone areas, they're often the most vulnerable. Their needs, their experiences, their voices, those have to be at the heart of any plan we come up with.
That's so important. We can't just come in with some top-down solution. We have to really understand the reality of what people are facing on the ground. What are they already doing to cope? What are their biggest concerns?
Exactly. And it's about combining that local knowledge and traditional practices with some of our modern approaches. And there might be age-old techniques for flood mitigation that we've forgotten about.
It's respecting the wisdom of people who've been dealing with these challenges for generations. Now, speaking of modern approaches, what about infrastructure? What kind of changes would we need to make communities more resilient to these floods?
Well, we need to rethink how and where we build. We need to invest in structures that can withstand flooding. Things like elevating critical buildings like hospitals and schools and creating those natural buffer zones that can absorb the excess water. It's all about working with nature and not trying to fight against it.
So we're talking about things like restoring wetlands, planting more trees, creating those green spaces that can act like giant sponges when those floodwaters start rising.
Exactly. And these nature-based solutions not only help reduce the flood risk, they also have all sorts of other benefits like improving air quality, increasing biodiversity, creating these beautiful areas for recreation and community building. It's a win-win situation.
It's like we're building resilience into the very fabric of the community. Now, what about early warning systems? How can we make sure people have enough time to prepare and get out of harm's way if a flood's about to happen?
Early warning systems are absolutely crucial. We need those reliable communication channels that can reach everyone, even those in more remote areas, and provide them with accurate information in a timely manner. But it's not just about issuing the warning. It's about educating people on what to do when they get that warning, giving them the power to keep themselves safe.
So it's about creating a culture of preparedness,
Hmm.
making sure people understand the risks and know what steps to take and have what they need when the floodwaters rise.
Exactly. Shifting from a reactive approach to a proactive one, anticipating the risks, planning ahead, and really building that resilience into the community. That's how we can truly protect people and their livelihoods when these floods happen.
I want to circle back to the machine learning part for a second. It's really incredible how these models can take such massive amounts of data and then pinpoint these flood-prone areas with such accuracy. But I'm wondering, are there limitations to what they can tell us? Are there things they can't predict?
That's a really good point. As sophisticated as these models are, it's important to remember they're still just tools. They're based on the data we have and the factors we choose to include, so they can't predict the future with complete certainty.
Right. There's always that element of the unknown. And things like climate change, which is changing weather patterns in unpredictable ways, can really throw a wrench in things.
Exactly. And the models are constantly evolving as we get more data and we understand these systems better. But we do need to be aware of their limitations and use them responsibly.
We can't just take them as gospel truth. And I imagine data availability is also a big challenge, especially in a country like Nepal, where access to reliable high-resolution data might be limited.
You're absolutely right. Those data gaps can definitely impact how accurate and reliable the models are. But the good news is that there are more and more open source data platforms popping up all the time, which is making that crucial information more accessible.
That's good to hear. The more data we have, the better equipped we'll be to tackle these problems.
Exactly. Data really is the lifeblood of these models.
Yeah.
It helps us see those patterns and make those predictions and develop those solutions. And as that data becomes more accessible, it just opens up so many possibilities for machine learning to revolutionize how we manage flood risk.
It sounds like we're on the verge of a major shift in disaster management, moving away from just reacting to these events and towards predicting them and preparing for them.
Yeah, it really is an exciting time to be working in this field. The possibilities are endless, and the potential to help people is huge. We have the tools, we just need to make sure we use them wisely.
And that brings us back to those city planner hats of ours. Because in the end, it's not just about the technology, it's about working together, being innovative, and putting people first. It's about using these powerful tools to build a safer, more resilient future for everyone. It's amazing to see how these tools are helping us go from reacting to these disasters to actually predicting them and preparing for them ahead of time. And it makes you wonder, can this machine learning approach be used to predict flood risks in other places around the world? Could this be like a global solution?
Oh, absolutely. That's one of the most exciting things about these models, their adaptability. The same principles that were used to assess the flood susceptibility in the Karnali River Basin can be applied to other river systems that are facing those similar challenges.
Yeah.
Of course, the specific factors and how much they matter might need to be adjusted, but based on the unique characteristics of each region. But that core approach is incredibly versatile.
So it's like having this customizable toolkit for flood prediction. We can adapt it to all sorts of environments and situations.
Exactly. And as we gather more data and these models get more refined, their predictive power is only going to get stronger. Imagine a future where we can predict these flood risks with even greater accuracy and give communities the information they need to take action and stay safe.
That's a pretty powerful vision. A world where we're not always caught off guard by these natural disasters. We're a step ahead, prepared, and ready for whatever might come our way.
And this shift isn't just about technology either. It's about creating a culture of preparedness, empowering communities to take charge of their own safety, and really building resilience into our societies.
Well, this deep dive has really been eye-opening. We've gone from the Himalayas to the world of machine learning, and what's really clear is that data can really light the way to a safer and more resilient future.
It's been great exploring these important issues with you. And remember, knowledge is power. And by understanding these forces at play, we can work together to reduce those risks and build a brighter future for everyone.
Kind of said it better myself, and to all our listeners out there, we hope this deep dive has sparked your curiosity and encouraged you to really think critically about these challenges and the opportunities that lie ahead. Until next time, keep exploring, keep asking questions, and keep learning.